Hi, everyone. Welcome to this UTXO Alliance technical presentation. Today we have presenting Andrew and Ivan from Bitcoin OS and Charms. And without further ado, let me hand the floor over to them and we'll start this presentation and then have some questions afterwards. Thank you.
Okay, perfect. So first of all, thank you guys for inviting us, UTX Pro Alliance. It's been very heartwarming for us at the Charms team and at the Bitcoin OS team to have uh, gotten such a warm reception over the past uh, few weeks, a month and a little bit about our technology. Many people have wanted to hear about it, and that's great to see because it's been something that's been in the works for uh, a number of months now, almost a year at this point. And it really only got on the map a little more than a month ago. And the reason it got on the map a little more than a month ago is because OS sort of came out of left field with an announcement that they'd done something that nobody in crypto had done before, which is the first bridgeless cross-chain asset transfer between the Bitcoin chain and the Cardano chain. And we suggested that what we used to do this was an all new form of UTXO-based magic. So immediately in the aftermath of that, there was tremendous excitement from some more technically minded people, some more skeptical people. They thought, what does that even mean to do a bridgeless transaction, and how on earth is that even possible? And so we held back on the exact technology and the full explanation of what that entailed for a couple of weeks until on May 22nd, Bitcoin Pizza Day, we released the white paper for Charms. Charms is the underlying technology that Bitcoin OS used in order to move BTC from the Bitcoin chain to the Cardano chain, quote unquote, bridgelessly. And so today we're going to talk all about that Charms technology and what exactly we mean by the term bridgeless. And the core of this technology is that it's unchaining UTXO-based assets using ZKVMs. No bridges, no custodians, and no compromise. Ivan, could you go to the next slide? Perfect. So let's start with the problem that we're aiming to solve. So Bitcoin, as we know it today, is a resounding success. It's the king of crypto, and now it's an extremely non-controversial ledger and asset that basically everybody wants to integrate with, including the US government, including BlackRock, Fidelity, and there's now a slew of Bitcoin treasury companies, MicroStrategy, and a number of them afterwards, which are printing their own stock in order to accumulate as much BTC as they possibly can. And yet, in spite of all of that, we still see much greater potential in Bitcoin. And anybody who's on the developer side knows that Bitcoin is limited in all kinds of ways, that it's just not unlocking its full potential. So one way is that it has no smart contracts. So it's difficult to do advanced decentralized applications on Bitcoin like DeFi. It doesn't have any strong interoperability with other chains, largely because of the fact that it has no smart contracts. And so if you wanted to, say, use another blockchain in order to enhance its functionality, moving your BTC over to that other chain is going to reintroduce massive trust, which kind of defeats the whole purpose. And there's no tokens on the Bitcoin blockchain, at least not inherently or natively. And so you have this extremely pristine asset called BTC, and yet there's no strong digital economy around that digital money. And so, what this has created since Bitcoin's inception is a number of developers that tried to build on the Bitcoin chain, realized that it was getting too difficult, realized that the Bitcoin community was dedicated to not changing the code of Bitcoin to be more welcoming to other applications. And so they moved over to other chains to try and build other apps. And while other apps have flourished on other chains, they don't have nearly the same network effects or brand appeal or security or trust of the main Bitcoin blockchain. And so you've had this split between the most strongest, most trusted asset and network and the actual decentralized applications that are being built with blockchain. And so what people have been looking for forever now is how can we merge these two worlds together again? And that's where we get into the technology that we're going to present today, which somehow solves both at once. So Charms introduces programmable, portable tokens on Bitcoin and other UTXO chains using ZKVM proofs and client-side validation. So what inspired this new protocol that we've developed is the the genius of the technologies built on UTXO chains that came before it, in particular Bitcoin and Cardano. So first, there's the Cardano extended UTXO model, which proved that programmable tokens can exist on UTXO-based blockchains. And you can have tokens exist inside of UTXOs, and the token preservation rules can be enforced by the UTXO ledger itself instead of needing a special smart contract to, say, track the entire state, as is the case with an account-based model. Then we have the ordinals and runes revolution, and really the Bitcoin meta protocol revolution, which came after, really just starting a couple of years ago, which showed us an entirely new paradigm for how innovation on Bitcoin can take place. It showed us that we can innovate, create new applications for Bitcoin without building another blockchain, without requiring some kind of L2, which again breaks Bitcoin's network effects, and which doesn't even need to change Bitcoin's code. And the way to do that is with client-side validation. So you can run an additional piece of software or a node alongside a core Bitcoin node. And this node can choose to interpret what's going on in the blockchain and write to the blockchain in its own subjective way that effectively imbues Bitcoin with functionality that a regular Bitcoin node doesn't recognize. And so this was originally used in early 2023 to start minting ordinals and then BRC20 tokens, and there was a whole meme coin rush and everything on Bitcoin, and people started to wake up to the fact that wow, it now has this functionality that we didn't even think about being on Bitcoin or there being a possible way to introduce it. And so Charms builds on that paradigm of using client-side validation to say, what if we could use CSV to project functionality on the Bitcoin, much like the functionality that's been built onto Cardano already using its own UTXO model. And so that's where Charms comes into play, and it introduces Cardano-like functionality to Bitcoin and then some. I'll let Ivan take over from here.
Yeah, so I'll just continue what Andrew started, and that means that so with inspired by Cardano's extended UTXO model, and for adding tokens to UTXOs, not just the base asset of the chain, and with ordinals and runes, introducing meta protocols to Bitcoin. So what we decided to do, we wanted something that would be on top of Bitcoin, so tokens on top of Bitcoin, but they needed to be programmable. So and the insight came from like, hey, we can use client-side validation for this, but we don't want to traverse the history, and we also want programmability. So what do we do? We obviously cannot have, and we don't want additional nodes to run. So because that would introduce additional trust assumptions. So we didn't want to create a layer 2. And this is what we came up with. So we came up with an insight that we could, just as ordinals and runes do, we could add some metadata into a Bitcoin transaction. But we decided, okay, that metadata could be a ZK proof of adding additional tokens to the transaction. And that ZK proof could be verified not just by special nodes, but by everyone. So anyone looking at a transaction would look at that ZK proof, and they decide for themselves if they want to ignore it or they want to say, oh yeah, I recognize these tokens here. So and now let's talk about how we structure these tokens, what they are, what they are in essence. So what is a charm? A charm is a key value pair of app and the application's data with regards to a particular UTXO that the charm is assigned to. And some examples would be, let's say there's a fungible token in some amount in an output. The data would be the amount of that fungible token in that output. But what is an app really? So an app is specified by 3 components, which one is a tag. It's a little character that specifies if the app is a token or a fungible token, an NFT, or something else entirely. So and tokens and NFTs are being special cases for the apps. The app's identity. So if that's just the 32-byte string that that is unique to this particular instance of the app. And for example, each NFT would probably have their own identity. And verification key is again a 32-byte sequence that we could look at as a hash of the application code. So, and this gives us an elegant model where every UTXO becomes a collection of charms. We can call it a string of charms. And this enables composability. This enables things like, okay, we can have a limit order where we trade a bunch of tokens, NFTs, what have you, for something we desire. And what we desire is written precisely in the limit order data. And limit order itself is a charm. All the other charms in the same output would be something we offer in that limit order. Or we can have like artist royalties, like say a charm would specify that the NFT in this output, or multiple NFTs in this output, cannot be spent without paying the royalty. So you would not be able to unlock these NFTs without destroying them. So yeah, a caveat here is that every charms output, at least on Bitcoin, is spendable by the private key holder of whoever owns the UTXO. So obviously, if that UTXO is spent to say I don't know, pay a transaction fee, all the charms are gone. But the same goes for any valuable possessions, even in the real world. Like you can have some banknotes which you can easily burn. So we figure that it's not so much different. But on the other hand, this could be handled carefully and preserved and transformed according to the rules. So this gives us pretty much limitless possibilities for applications on UTXO-based chains, including Bitcoin and Litecoin. So I started talking about ZKVM proofs. So the applications are coded in Rust, implemented in. We wanted these applications to be implemented in a programming language that ordinary programmers could understand. So not some specific blockchain specific language, nothing exotic, but not a language that allows you to encode ZK circuits, but rather a language that would already be popular, and so anyone could write. So Rust is the first one because it has pretty good tow chains compiling to RISC-V, our current binary format, but we are going to introduce WebAssembly as the binary format. So pretty much any language, including JavaScript and Python, would be able to be used to encode logic for Charms assets. So yeah, I just talked about this, and so yeah, let's talk about the exciting part, which is beaming. So this is a surprising, I would say, consequence of a design of Charms, which we didn't fully realize at first. So as I mentioned, I was tasked with designing a programmable token standard for Bitcoin. But in the process, we discovered that if we only design it in such a careful way that the application contracts do not concern the underlying transaction, basically, we can overlay these assets on top of any UTXO transaction, meaning we could take any UTXO based chain and put these tokens there. Not only that, we could even conceive of a scheme where we could erase the output, or rather the meta layer output from one chain and create it on another chain with a chain of proofs that would allow us to effectively beam these tokens from, say, Bitcoin to Cardano. And by beam, I mean in pretty much literal sense, as shown in TV show Star Trek. So Captain Kirk and the crew would be beamed from Starship Enterprise to a planet, and then back from the planet to the starship. So effectively disappearing from one place and appearing at the other place. And I would let Andrew talk about a little more about use cases, and then we'll open up for questions, which actually I have a few diagrams to go into details, and I can also show you some source code. So let's wrap it up.
Yeah, so these are just a few of the initial use cases that we've thought up that that Charms could introduce to Bitcoin or to any of the other UTXO blockchains like Cardano, which may or may not have some of these applications already, but Charms definitely presents a vast improvement. The number one application, and the one that everybody's mostly excited about in public right now, is Enchanted Bitcoin, EBTC. This is the name for a wrapped version of Bitcoin that we're creating with BitcoinOS in order to take one BTC, lock it up on the Bitcoin chain, and issue a wrapped version of BTC still on the Bitcoin chain as a charm. And once this Bitcoin charm exists, this is the ultimate interoperability solution for BTC. Because once it's a charm, it can be seamlessly, just bridgelessly beamed over to any other blockchain without having to constantly go through other bridging infrastructure. Now, in terms of practicality, this is a vast improvement for building interoperability between chains. Instead of having to build a number of, say, competing bridge protocols or like different bridge protocols between all the different chains, say when Charms expands to other blockchains like Bitcoin, Litecoin, Dogecoin, Cardano, instead of having to build a bridge between Bitcoin and Cardano, Bitcoin and Dogecoin, Bitcoin and Litecoin, et cetera, Charms can be this universal protocol, this super highway for transferring your BTC between these chains. And it's much simpler to integrate at a practical level. And on top of that, really the initial idea behind the eBTC innovation is just to turn BTC into a programmable asset on the Bitcoin chain. So with Bitcoin security, L1 guarantees controlled by your Bitcoin private key, you can now hold a version of Bitcoin or of BTC on Bitcoin that can interact with smart contract applications. So a real equivalent for this is it's like the same innovation of wrapping ETH on the Ethereum blockchain into WETH. So now this is a new eBTC token that is smart contract compatible. So that would be one of the largest innovations. Other innovations that we're exploring that could theoretically be possible could be something like a peer-to-peer Bitcoin on-ramp. So one of the great things that's plagued Bitcoin and crypto forever is the idea that in order to get into the crypto sphere to begin with, basically everybody has to go through some kind of centralized means. You have to go through a centralized exchange. That exchange will KYC you. You have to follow all of the rules of dealing with some kind of intermediary for your money. A P2P Bitcoin on-ramp could potentially be constructed using the ZK technology behind Charms. So what you could do is simply build a system where Cash App, peer-to-peer Cash App transactions are verified using ZK. And then once they're verified having taken place, the URL of one of these Cash App transactions, you can build a system where BTC is released to the buyer once they've made a peer-to-peer payment. Now, the key here is that Cash App itself would have no idea that these transactions are taking place for Bitcoin. It just looks like an ordinary peer-to-peer transaction. But we can build an application effectively on top of Cash App that uses the Bitcoin blockchain so that when one transaction is confirmed to have been made to another person, BTC is released from a smart contract, or eBTC is released from a smart contract on the Bitcoin chain, and it goes to the buyer. So this is a way people would be able to onboard Bitcoin digitally in a peer-to-peer way without any official middleman involved, and therefore avoiding KYC. Another applications which use a similar technology could even be a self-auditing stablecoin. Imagine that you're able to use ZK to verify balances, say in your Cash App account or your Venmo account off-chain, and then use the verification of those balances to determine the rules around how many stable coins you mint on Bitcoin. Bitcoin can now have fungible tokens and non-fungible tokens through Charms. One of those fungible tokens could be a stable coin. And if you have stable coins on Bitcoin, that could be the real introduction of getting people to start using the Bitcoin ledger as a payments mechanism, and then by extension, turning BTC into a payments currency. So the idea here is that Charms isn't just unlocking programmability for Bitcoin, and it's not even just building connections between Bitcoin and the rest of Web3, but ZK can allow it to connect with the Web2 and the traditional finance world as well, and make that transition between the worlds seamless and decentralized. So let's go to the final slide, Ivan. So that would be it. We now have one post-chain meta protocol for tokens that can unlock one seamless united internet of value. So prepare to feel the magic. And our links are below. You can follow me, you can follow Ivan, follow the Charms account, and you can visit the Charms website to have a look at some of our open source code, have a look at the full white paper. That's all we've got to say.
Wonderful.
Yes, yeah, very well said. Yeah, I can share some diagrams right now. Actually, let me just real quick.
Yeah, that would be great, Ivan. If you wanted to just briefly show or say anything about those, and then if people want to ask questions, you can raise your hand and come off mute after we call your name. And then otherwise, if people aren't willing to ask their own questions, we'll have a few in chat that I can read off, or that the one of you can read off. So back to you, Ivan.
Yes. So here is the picture of. So I wanted to visualize how Charms fit into the underlying UTXO transactions. So here we see three transactions: TX1, TX2, TX3. So all of them have transaction outputs, and we can see that the first one has no charms in its first output, or perhaps it does, but we don't care about those. Has some fungible tokens in its second output. The second transaction has a bunch of BOS tokens and a huge amount of USD and an NFT. And all of these, we have this transaction TX3 that takes these inputs, spends them, and reshuffles the fungible tokens and the NFT into its outputs. This is what we consider a simple transfer, as there's nothing minted or burned, but it's still an interesting example. It shows us that, well, basically how charms are assigned to transaction outputs. And let me zoom into transaction 3, which what allows this to happen is these things called a spell and a proof. These are just binary data encoded as CBOR, put into the witness of the last input of this Bitcoin transaction. On Cardano, obviously, it's a little different. But as a meta protocol, by the way, on Cardano, we don't have to create another transaction to commit to this data. It's just the implementation detail of where it is put. On Cardano, we could just create a change output and put all of this into the data, which is exactly what we did when we did the demo. So anyway, let's talk about the spell. So we can see that we have a bunch of apps listed here, and these are for to preserve space. We also add the public data, and any additional public data will also be here. In this particular case, because it's a simple transfer, we don't really need any additional public data. If we were, say, minting some tokens, we'd probably have some data here in the values. So anyway, these are all the apps, and the interesting part here is also outputs. So we have 3 outputs, 0, 1, 2, and say output, the first output takes apps with indexes 0, 1, 2, 3. So these 4, 1, 2, 0, 1, 2, 3, and say the output, so the first output has 511 tokens of what would we put 0, 1, 2, 3. This is CUSD. So and let's just take another example. So the output number 2 has 39 tokens of contract 1. So that'll be charmed ADA. So these are all assigned by the spell. So, and if we could just leave it here and do it like this, but we'd need to traverse the blockchain to ensure that this spell is correct. We don't want to do that. That's why we need to include a recursive zero-knowledge proof that this data is correct here, so that we actually have the right to include these tokens in the outputs of this transaction. So they have to come from somewhere or be minted in a legitimate way. So that's why the proof exists. And what the proof is attesting to, the proof is basically saying that the is spell correct predicate for this transaction is true. So what does this mean? This means that is spell correct for the previous transaction is true. That's the recursive part. And that each app contract invoked with the app specification and the transaction itself, meaning the spec of all inputs and outputs, in addition with public data, private data. And so this means that the contract for all of these arguments evaluates to true. So what physically happens is that before the transaction is put on chain, we need to execute each. First, we need to construct the transaction without the spell, or rather, we need to construct the spell itself like this. Then we need to run each and every application contract producing a proof, and then we need to fold all these proofs. Like we also need to verify the proofs in the previous transactions, and we need to run this whole. That's what the Charms CLI does, and what the Charms Proving Service does. It runs the program inside the ZKVM, which produces a proof of this statement, and this proof is then wrapped into a Gross16, a ZK snark, and it's put into and it just takes a couple hundred bytes in the transaction. So all in all, this data in a transaction for simple transfers, it's like 700, 800 bytes.
Hey guys,
Yep.
I am very sorry for being late. We've had a crazy couple days. Apologize.
We're still we're covering a few things. Ivan's going over some things from the protocol.
I have just finished my speech about the diagrams here. So yeah, questions very welcome.
I think that there
We
were
can
some
start
good
with
questions in the
chat.
the chat there.
Yeah, okay. Let's get started with them.
Yeah.
So okay. So one of the questions is how can we verify that there isn't actually a bridge in the bottom of this infrastructure? A great question. So what Andrew mentioned about our first use case, the enchanted BTC, there is a bridge, but it's a bridge from Bitcoin to Bitcoin that works in your wallet. Or that's how we envision it to work. So basically, what is being done is that real Bitcoin is being locked in a UTXO output, in a Taproot output, and eBTC is minted in the same exact amount and put in your wallet. So that's the bridge part. The bridgeless part is now to transfer this eBTC or whatever Charms tokens you have. You can actually do that without a bridge. So to do that, what you need to do is, let's just say this output here, we are bridging it, or rather beaming it to Cardano, for example, or any one of these outputs. So what we're doing is we put a little property, beam to, and we put a hash of the target UTXO on Cardano. So in order for this to happen, first that UTXO, the placeholder UTXO, needs to be created on Cardano, and its ID is hashed and it's put here. So now later here, if say someone wants to spend this output, they can't because these tokens are no longer here. So they are marked as being beamed to some UTXO with this hash, and that's all for this part of their life on this blockchain. But on Cardano, when you want to spend these tokens, you actually are spending that placeholder UTXO. What will happen is that a transaction. So our ultimate vision for Cardano is to have Charms be available as Cardano native tokens. So what we'll do is we will recreate that placeholder UTXO, but with actual tokens. So we'll take the proofs of. Well, first of all, we'll take this transaction. We have it. This transaction in hex form. It has a proof, right? So the ZK proof of solve. We verify this proof, obviously. So that means that all of the previous transactions of this also have valid proofs. We also take the proof of inclusion of this transaction in a block, and the proof of sufficient work performed on top of that block. So all of these need to be presented as evidence when recreating that placeholder UTXO with actual tokens on Cardano. So as a result, we'll have basically this UTXO appear in its entirety on Cardano, but it will also have some amount of ADA, obviously, as well. So that's how it works. So did I answer the question?
I think you
did.
I'm wrapping my head around it, but you can proceed to the next question. No problem.
Okay. Thank you, Steph. So what are the trade-offs of this approach? Well, there are, of course, trade-offs, obviously, as in everything. So, like, for example, we can create a UTXO on Cardano, and that UTXO would be not a placeholder UTXO, but it can actually have charms in it already. So what effectively will happen is that these Beam tokens, well, they would not be able to be used because now this transaction is already on Bitcoin. So there's no way we can redo this, right? So and on Cardano, we can no longer spend these tokens. We'll like these will be burned. So that's a beam malfunction. It would be. So yeah, this beaming is going to need to be implemented inside the wallets, and it has to be implemented correctly. So, and obviously there's a trade-off for this whole thing, even on Bitcoin. I mentioned briefly that one can spend the Bitcoin UTXO in any way that's allowable by Bitcoin. So Bitcoin itself doesn't know about charms, right? So your wallet, your wallet should use a charms library to look at the transaction and see these charms. So these are some trade-offs. The next question is, what is the standardization necessary for other UTXO chains to adopt charms? So for Cardano specifically, we are working to implement charms as CNTs, as I mentioned. So that would mean any fungible or non-fungible token, charms token, would be represented on Cardano as a CNT, and any kind of non-standard or non-token charm, this will probably introduce some data stored in datums of Cardano outputs. So I would say there's every blockchain is different. Therefore, each blockchain has to kind of have their own implementation. But all of these implementations are going to plug into basically the charms software. So we're using kind of the same approach as Guido van Rossum did with Python: implementation first, specification next. So that's the code is the specification. A nice part of it is just you can send a PR, and if it gets merged, then that's your functionality now. That's how it's implemented. So, but people care about working code anyway, rather than documents. So let's see. What level of VM integration is needed within the given chain's ledger validation logic? Question from James. So what is the requirement for charms to support a different instruction set or architecture? So we currently support app contracts compiled to RISC-V, and it's not just any RISC-V. It's actually very specific to a specific ZKVM that we're currently using. So succinct SP1 was we were lucky enough to see that it already works and it does what we need. So we simply decided to use it. But the kind of the format for the verification key is simply 32 bytes, right? So every asset's verification key is 32 bytes. What these 32 bytes mean is like we assign that meaning. So and also the ZK proofs are simply Groth 16 proofs. So these are fairly standard. We are thinking about migrating to a different VM though, because what we need from our ZKVM is the ability to prove programs compiled to WebAssembly, as I've stated before. So with RISC-V, it's a nice processor architecture, very simple, very easy to create compilers to, but it is very low level. So tool chains only for, say, Rust, basically, and C and C++ exist. But nobody is going to use LLVM to, compile to a RISC-V in a very particular way. People would want to use something standard, something already very widespread. So that's why we need WebAssembly to be our binary format, and that is the standard right now. It's like every piece of non-trivial code running in your web browser, say like a video player, is already compiled to WebAssembly. So we're just going to use that. And the proofs are still going to be Groth 16 snark proofs. So the size of the proofs are not going to change. Is Taproot a requirement for charms? On Bitcoin, 100%. Taproot is implemented. So as we mentioned, we were heavily inspired by ordinals and runes, and these are implemented using Taproot. So yeah, Taproot is a requirement on Bitcoin. Later, we discovered that say Dogecoin doesn't have Taproot, but it has something called Dogenals, which means that data can be stored in Dogecoin transactions. Therefore, we can probably implement charms for Dogecoin, so we probably will. And Dogecoin doesn't have Taproot. So Cardano doesn't have Taproot, and we implemented charms in Cardano as a meta protocol. So again, what we needed was simply to be able to store data in a transaction, and we can easily do that using a datum, and that's what we did. So pretty much, if a transaction can store additional data, and what we need is a few hundred bytes, then charms can be implemented in such transactions. Next question.
Can I tackle this one, Ivan?
Oh, for sure.
Yeah, so from Canon Q, he says, I'm an end user, not a dev. How does the EVM token interact with the protocol you described, if at all? So, as mentioned, in every way possible, we're trying to design charms so that it's backward compatible with the existing token standards on large chains once Charm's integrating with that chain. So the first example of this that we're doing it with is Cardano. So if a Charm is beamed over to the Cardano blockchain, it will land there as a CNT in the user's wallet, so that any wallet that's already compatible with CNTs can just see it as a CNT. Any explorer that already just looks at CNTs, it can see it that way. So on that level, if we were to do the same thing, build a similar protocol, say with EVM chains, so that it can interact with ERC20 tokens that way, that's how they would interact. And by extension, any wallet that supports ERC20 tokens or the EVM chains, if they integrate the Charms protocol, they'll be able to beam their existing ERC20 tokens as Charms over to other blockchains. So that would be the level of integration. This is a good one. Probably a very basic question on BTC. When the coin is locked, who can unlock? Only team, or can I run this code base myself? And then some similar questions. Again, number 4, who holds the BTC that is bridged to eBTC? So, right, as mentioned, and this is something that needs clarification again and again. BTC itself still needs a process by which it gets wrapped or bridged, if you want to call it that, in this case, into a charm before it can then be beamed to other chains. It needs to be transformed into eBTC. That process does introduce some level of new trust assumptions for BTC when you're going through this process. Now, thanks to many technologies that have been developed, are being developed over the past year, including by BitcoinOS, we're finding a way to minimize the trust assumptions around that wrapping or bridging process to like the smallest possible degree. So right now, BitcoinOS has for some time now building a technology called BitSnark, and BitSnark is essentially it builds upon the BitVM paradigm that began in October 2023, but improves it in order to specify it for the purpose of verifying ZK proofs, and in particular to build an app that we were initially calling Grail in order to trustlessly or in a trust minimized way move BTC from one blockchain into another. The trust assumptions around that wrapping process are a 1 of n trust assumption, or an honest singleton assumption. So anybody can go and go into the bridge, mint some eBTC. Anybody will be able to come out of the bridge and like withdraw their eBTC into regular BTC. But the transactions around deposits and withdrawals, the legitimacy of them will be verified by a decentralized set of verifiers who can look at the proofs that are being used as part of the smart contract that controls your underlying BTC, and say if there's any illegitimate withdrawal that tries to take place, if there's just one honest verifier looking at that and can check it and can prove that like this is an illegitimate withdrawal, then they can stop the transaction from happening. And if there's an operator that tried to process that withdrawal, they'll get slashed. The dishonest party ends up getting punished. So this is part of a new set of technologies, again, that people are making to make the Bitcoin wrapping process as trustless as possible. Some might, depending on the semantics used, some might say that's already a trustless system. Some people are looser with the term trustless versus trust minimized, and it gets a little bit complicated there. But the bottom line is that's a 1 of n system for BTC. And that's for BTC in particular. If we're talking about a token that has been natively generated as a charm, say I create Andrew token today, and it's natively a charm. As a charm, in its purest form, this truly can be just trustlessly and bridgelessly moved to another chain by just beaming without having to rely on a third party. All you need to run if I wanted to move that token from Bitcoin to the Cardano chain would be a Bitcoin node, Cardano node, and a Charms client, all of which I can run on my own. I see you asked a number of questions. I want to make sure I got to them all. Will this work with all wallets or selected wallets? So again, wallets that, in order to get the full benefits of Charms, they'll need to integrate the Charms standard, particularly to be able to take those Charms tokens, see them if they exist on the Bitcoin chain, and to be able to beam those Charms tokens to other chains, they'll need to integrate the Charms software. even then, Charms tokens will be designed to be backwards compatible with existing token standards. So if there's a Cardano wallet out there that doesn't integrate Charms, but it just recognizes CNTs, a Charms user could beam a token into another Cardano user's wallet that doesn't support Charms normally, but the recipient will still be able to see those Charms in their wallet just as a CNT. So it's backwards compatible in that way. Yeah, I think that's all of them.
Okay, let's see what else we have. So we have, what if any benefits might Charms derive from adoption on chains that support more complex transaction validation? So if a chain has an on-chain capability of verifying ZK proofs, then we can probably make Charms tokens represented as native tokens on that chain. I would say so that's the benefit of more complex VMs. So like, for example, Cardano has built-in functions to perform elliptic curve operations on a pairing-friendly curve BLS 12-381 that allows us to verify gross 16 proofs over that curve on Cardano. So boom, we can represent Charms tokens as CNTs, as native assets on Cardano. Same goes for, say, Sui. We are obviously have a whole backlog of things, but we could possibly talk about implementing Charms as native tokens on Sui. Not sure about Ethereum, but theoretically it is possible to even implement Charms as ERC20 tokens with some caveats. But yeah. And what benefits I would say I would add, implementing Charms adds to a blockchain is well, the chain becomes a execution layer or DeFi layer for Bitcoin, which is, I think, pretty valuable. Okay, so next question is, it sounds like there's a non-trivial and critical level of trust with the wallet to review Charms. Well, yes. So Charms is a fully client-side validated protocol. Means that every client decides for themselves whether they and how they interpret Charms. So the thing is that, like, say, I might have my own interpretation of Charms and perhaps recognize it or process it in a very different way. And so let's say I look at the transaction, at the latest transaction, perhaps I recognize the zero knowledge proofs there, and I send something to Andrew. But I do that. I create that transaction in a non-standard way from the point of view of the latest version of the Charm software that Andrew has. So Andrew looks at that transaction and he sees, okay, that proof doesn't check out. So, oh my God, what's this? Yeah. So and therefore Andrew will not recognize this. So and consensus here, I would say it's more of a social consensus. So yes, it's kind of the same way as Bitcoin users trust the Bitcoin software that comes from the Bitcoin repo on GitHub. In this way, we can all say, now actually Microsoft owns Bitcoin because Microsoft owns GitHub. Therefore, we all trust Microsoft. It's kind of the same way. Yes, there is a trust assumption that yes, the software comes from the Charms development team. It's all what all the users have to trust. Okay. Are there any potential design patterns that utilize partially signed Bitcoin transactions? So users collaboratively create state transitions. Well, a like a charm spell can be potentially put on top of any draft Bitcoin transaction. So PSBTs could be used to create a transaction, to construct a transaction, and then we could put a spell on it, and then have the transaction signed by the parties, by all the parties that related to any inputs in that transaction. So these are completely orthogonal. Next question I see. Grail aspires to be the rollup VM intermediary to simplify building one side of the bridge from Bitcoin to X chain. Well, yes, that indeed is the case for EVM-based chains, and that was the initial vision of BitcoinOS before Charms came into picture, and still is for the current EVM chains. So yeah, I think Andrew can tell you more about this. And Andrew, I think you're muted.
Thank you. How do you envision Grail operators to manage their computer resources? Will they be running a Bitcoin node client and a Grail client simultaneously? So Grail operators will be running what's called a SLAM node. So a SLAM node stands for Service Level Agreement Maintaining Node. And so these operators are they're meant to be, say, power users of the system. They'll need to hold BOS token in order to operate. When they do this, they'll be responsible for a lot of the proving and verification services in order to be able to perform direct withdrawals from the Grail bridge as initially envisioned. To also produce the proofs involved with the communication with other blockchains, et cetera, verifying proofs. One thing to note is that there will be a separate type of node called just a BOS node, in which you don't need to hold the BOS token to run one of these nodes. It's not going to be as computationally expensive either, in which really anybody can join in and do the bare minimum service of verifying ZK proofs. And so you would be able to look at that, look at the proofs being posted to the bridge, ensure that they're legitimate, and make sure illegitimate withdrawals do not happen. I hope that answers it.
And let's take that last question if you can, because I want to be respectful of time, Ivan. I know that you had a hard out here. So, Andrew, if you have anything left to say on the last question in chat, and then we can wrap up.
Sure. So this is from the one from Canon Q again. I was asking about the BOS token. Thanks. That is on EVM already. Do you need to use or spend some to use the protocol? How does that token work within the system construct? So the BOS token will be like pretty much a staking token involved in running a SLAM node. And a SLAM node is one of the nodes involved with ZK proving and verification between different chains. And one of the nodes involved in securing people's BTC in that locked smart contract on Bitcoin that is later on beamed over to other chains through Charms. You said BOS token is on EVM already. BOS token, well, TGE hasn't happened yet, but BOS token in its final form won't be an ERC20 token. It's going to be a Charms token, which means it'll live on Bitcoin first, Cardano second, most likely, and then be able to be beamed out to really any chain after that is integrated with Charms. And yeah, I think I answered the last part of that already about the BOS token and the Slam node staking.
Any last words guys. We really appreciate the presentation today.
I'd say just thanks a lot for having us, hearing us out. We're always down to answer these sorts of technical questions about how it all works. And yeah, you're welcome, Ken and Q. It's always great to be on in a space like this. For me personally, this is one of the more like technical audiences we've had, and like answering more technical questions. It's always nice to be in the room with such a bright-minded group of people for this sort of thing, and would always be glad to talk to you guys again.
So I would say, I would add to this that hey, please take a look at charms.dev, find steps to get started, read the white paper, try it out for yourself, create some meme coins, your namesake coins, as Andrew did with his Andrew token, and yeah, just have fun with it.
Amazing. Well, yes, put your Twitter links into chat. Everybody give them a follow along, dig into some of the documentation, and I'll share the recording afterwards. So thank you, Andrew and Ivan both, and thanks for everybody else for being here. Thank you.
It was
Great.
amazing.
It was fantastic.
Thanks.
And one more thing for Ignacio, BitSnark version 0.2 is open source. You can go and find it on the BitcoinOS website now.
Awesome. Thank you, guys.
Thanks.
Great presentation.
All right, take care, everyone. Bye.
Thanks, guys. Take care.
Thank you all.
Thank you.